Hi guys, welcome to the class. Today we will discuss the basic definitions in DC circuits. Let's continue with the class.
The sum of the currents entering at a junction is equal to sum of the current leaving that junction is called as Kirchhoff's current law.
The algebraic sum of voltages in a closed path is equal to 0, or voltage delivered by the active elements equal to voltage absorbed by passive elements.
The rate of change of flow of electrons is called as current. The units are amperes. Potential difference between 2 points is called as voltage, and the units are volts.
The current flowing through the conductor is directly proportional to the applied voltage at a constant temperature. I is proportional to V and V is equal to IR. This is the formula for Ohm's law. Classification of network elements. First one is active and passive elements. Second one, it is linear and non-linear elements. Third one, unilateral and bilateral elements. Fourth one, time variant and invariant elements. Fifth one, lumped elements and distributed elements. The elements which deliver energy to the circuit are called as active elements. The elements which absorb or stores the energy, those elements are called as passive elements. The elements which obeys Ohm's law are called as linear elements. The elements which doesn't obey Ohm's law are called as non-linear elements. The elements which offer same resistance if the direction of the current is changed is called bilateral element. The elements which offer different resistance if the change in current exists is called unilateral element. The elements which vary with respect to time are called time variant elements. The elements which doesn't vary with respect to time are called time invariant elements. The elements which can be separated and analyzed separately are called as lumped elements. The elements which cannot be separated and analyzed separately are called distributed elements. Series and parallel network. In series network, if same current flows through different elements, then the network is said to be connected in series. If different current flows through different elements, then the network is said to be connected in parallel. For a simple example, R is equal to R1 plus R2. So in case of series network, we have to add the elements. In case of parallel network, the resultant resistance is R1 R2 by R1 plus R2 if two elements are connected. Resistance is a passive element which opposes the flow of current. The units are ohms. And the formula from Ohm's law, it is R equal to V by I. Inductance is defined as flux linkages per unit current, that is L equal to psi by I. Units are Henry. Capacitance is defined as charge per unit potential. C is equal to Q by V, and the units are farads. Thevenin's theorem. In a linear, bilateral and time invariant network containing any number of active elements and passive elements can be reduced to single voltage source in series with single resistance. The voltage source is called as Thevenin's voltage and the resistance is called as Thevenin's resistance. Norton's theorem. In a linear, bilateral and time invariant network containing any number of active and passive elements can be reduced to single current source in parallel with resistance. Current source is called as Norton's current and resistance is called as Norton's resistance. Superposition theorem. In a linear, bilateral and time invariant network containing any number of active and passive elements, the combined response of active elements is equal to the sum of the individual responses of active elements. Transient. The behavior of inductor or capacitor in between two steady state conditions is called as transient. Capacitor does not allow sudden changes in voltage. Inductor does not allow sudden changes in current. So, as the time elapses, the inductor and capacitor, they change their properties. So if I take a charger, initially when it is switched off, the voltage is 0. So it will go from 0% to 100%. So the behavior of the inductor in between these two steady state conditions, 0% and 100%, is called as transient behavior or time response analysis. Circuit. In a network, if current starts and ends at the same point, it is called as closed path or loop or circuit. The rate of change of work done is called as power. In electrical terms, P is equal to voltage into current. The units are watts. The amount of power consumed in a given time is called as energy. E is equal to P into T. The units are watt hour, kilowatt hours.